Alright, this one says, determine the values of x for which the function as represented by the graph to the right is continuous. If the function is not continuous, determine the reason. So determine the values of x for which the function is continuous. Okay, so we want to know where it's continuous along the graph. And we see here a hole. And we see that point actually represented down here. So where is the function continuous or not continuous? The function is not continuous at x equals -1. Well, this is -1 over here, and so x is continuous there, right? I should have made it bigger, but this will do. So that's not right. The function is not continuous at 1, and that's where we see it right here. The function is not continuous at 1 because there's a hole there. And it should tell you that we can actually find the limit of this, but it's not continuous. So it's not continuous at 1. Although we will be able to find, it will be continuous if you can find the limit, but that's later on. Alright, the function is continuous for all values of x less than or equal to -1. Less than or equal to. All values of x less than -1 or equal to -1. Well, that's true, but that's not really complete. So let's not just go with that. See, that's wrong. That function is not continuous at -1 and 1. Well, we know it's continuous at -1. So that's not right. The function is continuous for all values of x. Well, no, it's not continuous for 1. So let's take that. The function is continuous for all values of x greater than or equal to 1. Well, it's not equal to 1 because 1 is here. I don't want to mess that hole up, but 1's there. So that's not right. And plus it doesn't include where it is continuous other than 1 on the lesser than side. Alright, is the function, oh, this is supposed to say y. So why is the function continuous or not continuous? The function does not exist at the point x equals 1, and a small change near the x value may produce a large change in the y value. The function does not exist at the point 1, and a small change near the x value may produce a large change in the y or f of x value. It seems like it could be right. A small change from x equals 1 produces a large change in f of x. That one seems right too. Function does not exist at the point x equals 1, and a small change. Well, actually, it does exist at the point x equals 1. Well, I mean, here, this little blue dot here. I'm just going to shade it in. That makes it continuous. Or maybe I'll take that off, but that makes it continuous. I mean, well, it's actually the function. It does exist at the point x equals 1. But it's not, in this representation, continuous. So let's see, the function does not exist at the point x equals 1. Well, that's not true then, because it does exist at x equals 1. And that's what that little blue dot is right there. So a small change from x equals 1 produce a large change in f of x. Well, it seems to. If you move 1 over, you only get kind of like 1 1/4 up, or this way you get 1 up. But if you go up like we were doing earlier, like, you know, if we went up like 5 on each side or something like that, it produces pretty significant changes, and I guess that's what they mean by significant. And I guess that's where maybe a lot of points drop off. I don't even know. But so that one's true actually. Function. Let's look at this third one. The function does not exist at the points. We already did that. It does exist at -1. The function exists for all points, and any small change in x produces only a small change in f of x. It doesn't exist at all points, and normally what they're trying to say is that there's a large change produced in f of x for a small change in x. The function does not exist at the point x equals -1. Well, they're really stuck on that -1, but it does. So a small change from x equals 1 produces a large change in x and y, I mean f of x, and the function is not continuous at x equals 1. So that's it for the second problem.